Hey guys, welcome back to another math video. Today we'll be showing you how to find all of the angles and side measures on a triangle using the law of sines. The law of sines states, in any triangle of ABC with angles A, B, and C, and opposite sides A, B, and C, respectively, the following equation is true. Sine of angle A over side A equals sine of angle B over side B, which also equals sine of angle C over side C. The law of sines is a very handy tool in geometry and trig, but in order to use the law of sines, the triangle must provide at least two angles and one side length. We'll give you guys a couple of example triangles to show you the law of sines in action. Let's start with an easy one. For this first triangle, we are given two angles and one side measure, and must find the other angle and side measures. Angle A equals 36 degrees, angle B equals 48 degrees, and side A equals 8. If you don't remember from before, the equation for the law of sines is sine of angle A over side A equals sine of angle B over side B, which equals sine of angle C over side C. The first value we are going to find is side B because we are already given angle B. Both values of A are already given, so we can use this ratio to find side B. To set this up, plug in the A values and the B values using the law of sines. This should end up being sine of 36 degrees over 8 equals sine of 48 degrees over B. And what we are trying to do here is isolate the B variable so we can find out what B actually represents. So the first step to isolate B is to cross multiply so we don't have to work with pesky denominators. If we cross multiply, we will get B times sine of 36 degrees equals 8 times sine of 48 degrees. From here, we must divide sine of 36 degrees out of both sides to fully isolate B. If you go ahead and plug 8 times sine of 48 degrees divided by sine of 36 degrees into your calculator, you should get about 10.115, which is our B value. Now that we have both sides and angles of A and B, we need to find the angle and side length of C. Angle C will be easier to find compared to its side length, because we know that all angles in a triangle must add up to 180 degrees. I like to write out this little equation, which is not necessary, but all you have to do is subtract 36 degrees and 48 degrees from 180 degrees, and you will get 96 degrees. So C equals 96 degrees. Our next step is to plug in our values into the law of sines equation. You should have the law of sines equation memorized by now, but if you need a refresher, it is sine of A over side A equals sine of B over side B, which equals sine of C over side C. Once again, I'm going to use our A values to find the side length of C, but since the law of sines states that all of the ratios are equivalent, you can use B to find the side length of C as well. From here, we basically repeat all of the steps from before to find C. We'll cross multiply again, which leaves us with C times sine of 36 degrees equals 8 times sine of 96 degrees. We'll isolate C by dividing sine of 36 degrees out of both sides. And if you plug what's on the screen into your calculator, you'll get C equals 13.536. That was the last value we needed to find, so there you go. You've just solved your first triangle using the law of sines. Here are all of the angles and side lengths all together if you missed anything from before.
So now we're going to give you an example with no solution. If you're given angle A and side length A, you know that you can use the equation sine A over A because you're given both of the values. You're also given side length C, which means that you could use the equation sine C over C as your other equation because at least you're given one of the values. So from here, you just plug it in. So it's sine 75 over 8 is equal to sine C over 9. And sine C is actually what we're trying to figure out. So from here, you just cross multiply. And you write it out as 8 times sine C is equal to 9 times sine 75. Now, in order to isolate sine C, you divide both sides by 8. And then if you plug that into your calculator, you should get sine C is equal to 1.089. Now, from here, you would, in order to find angle C, you would typically use inverse sine, or sine to the power of -1, and multiply that by whatever you got for sine C, which in this case is 1.089. But if you plug that into your calculator, you'll see that you get an error message. And now you may be wondering, like, what? I don't know, why doesn't that work? Well, just remember, anytime your value that you get for sine C, in this case is 1.089, is greater than 1, then that indicates that there is no solution for the problem. And in other words, that means that if your value is below 1, then you'll get a solution, but if it's above 1, then it'll be no solution.
For the third example, we have two solutions. With the given angle of A of 30, length A of 7, and length B of 8, we can use sine A over A and sine B over B. So sine 30 over 7 and sine B over 8, we can solve for angle B. Using cross multiplication, we can get 8 sine of 30 and 7 sine of B. And dividing both sides by 7, we can get our answer of 8 sine 30 over 7, and 8 sine 30 is equal to 4. So by using that, we can do sine B is equal to 4 over 7. And to find angle B, we can do angle B is equal to sine inverse sine of 4 over 7. So angle B is equal to 34.85. And to find angle C, we can simply just add 30 and 34.85 and angle C to equal 180. So by doing this, we can subtract 30 and 34.85 by 180 to get final angle C of 115.15. And with this, we can find the length C. And by doing this, we can use sine A over A and sine C over C. And we can get sine 30 over 7 is equal to sine of 115.15 over C. And by using cross multiplication, you can get 7 sine of 115.15 is equal to C sine 30. And by dividing sine of 30 on both sides, we can get 7 sine of 115.15 over sine 30 to equal C. So C would equal 12.7 using a calculator. So that is our first solution for example 3. To find your second solution, you can do 180 minus 34.85 to equal 145.15. And to find this new triangle, to make sure, you can do 145.15 plus 30, which you can find that is less than 180. So with that, you can find a new angle of C, which is 180 minus 145.15 minus 30, which you get 4.9. So with 4.9, the value of C length would be different. So instead of 12.7, you can find it by using sine 30 over 7 equaling sine 4.9 over C. And by using cross multiplication, you can get C sine of 30 equal to 7 sine of 4.9, not 49. So by dividing sine 30 on both sides, you can get 7 sine 4.9 over sine 30. So C is equal to 1.2. So this is our final solution. So thanks for watching, and I hope that you can incorporate these new concepts into future problems to figure out.